Europa rocket. The Europa rocket was an early expendable launch system of the European Launcher Development Organization ELDO, which was the precursor to the European Space Agency ESA. It was developed with the aim to delivering space access technology, and more specifically to facilitate the deployment of European-wide telecommunication and meteorological satellites into orbit. The Blue Streak missile predated the Europa program, having originally been developed by Britain primarily for military purposes. However, it was cancelled in 1960. Efforts to repurpose the Blue Streak, such as the studied Black Prince expendable launch system, eventually culminated in the multinational Europa program. Workshare on the program was shared between the various members of the ELDO based upon their financial contributions. The Europa launcher itself primarily consisted of the Blue Streak, Coralie, and Astris rocket stages. The program proceeded to perform multiple test launches, however these frequently resulted in partial failures. In addition, Britain decided to pull out of the ELDO organization, and thus Europa, to instead focus on the rival British Black Arrow launcher instead. This led to the replacement of the Blue Streak by the French-built Diamant section. However, confidence in the program had diminished due to the poor reliability figures, and this led to its termination. While Europa was ultimately cancelled, the ambition for such a launcher was still present and supported by the majority of ELDO members, and following its reformation into ESA in 1974, the agency proceeded to develop the Ariane family of launchers, which would prove to be a commercial success with hundreds of launches performed. Development. Background. During the early 1950s, the British government had identified the need to develop its own series of ballistic missiles due to advances being made in this field, particularly by the Soviet Union. A British program to develop such a missile, named Blue Streak, was promptly initiated. However, there were key questions over the then relatively unknown scenario of what such a vehicle would encounter when attempting re-entry to the atmosphere. There were fears that such a vehicle might simply burn up like a meteor and therefore be unachievable. Accordingly, during 1955, the Black Knight research rocket program was commenced for this purpose. Following several launches, the Black Knight came to be regarded as a successful program, having produced a relatively low-cost and reliable rocket, and thus there was impetus present to proceed with further development of the platform. On 13 April 1960, the Defense Minister Harold Watkinson announced the cancellation of Blue Streak as a military program, and went on to state that the government will now consider with the firms and other interests concerned, as a matter of urgency, whether the Blue Streak program could be adapted for the development of a launcher for space satellites. While development of the Blue Streak missile continued with the view of using it as a capable satellite launcher, the rate of work was substantially slowed. Aerospace author C. N. Hill wrote that this declaration had been made, mainly, I suspect, to minimize the political damage that ensued from the Blue Streak decision. In 1957, a proposed design, known as Black Prince, was put forward by Desmond King-Heal and Doreen Gilmer of the Royal Aircraft Establishment RAE during 1957. As envisioned by this proposal, an expendable launch system could be developed using a mix of pre-existing and in-development assets. The multi-stage launcher was to be formed of a Blue Streak first stage, a Black Knight or later a Black Arrow second stage, and a military solid rocket as a third stage. In 1960, the Royal Aircraft Establishment at Farnborough was given the job of considering how the Blue Streak missile could be adapted as a satellite launching vehicle, in conjunction with other rocket stages. Accordingly, the 1957 concept design for a combined Blue Streak Black Knight launcher was put forward once again, and this time received a favorable appraisal. The project was assigned the Rainbow Code of Black Prince. In official documentation, the platform was referred to as the Blue Streak Satellite Launch Vehicle BSSLV. However, it was quickly recognized that the program's cost would be a major issue. One estimate of the total development costs would have been equal of half of the Britain's university budget. Along with the high costs involved, it was becoming clear that due to British military satellites already being delivered by American launchers and the domestic science community being perceived as lacking the funding to conduct multiple major research satellite programs at once, that domestic demand for such a launcher was not guaranteed. Accordingly, it was decided that it would be preferable for other nations to be involved in the program in order to share the burden of the costs and to be predisposed to making use of the launcher. Diplomatic approaches were made to various nations, however, it became obvious that the members of the Commonwealth of Nations alone were not prepared to provide the necessary backing for such a program. Collaboration. As early as 1961, Peter Thornycroft, the Minister of Aviation, had been giving some thought on the topic of a joint European project, the main intention of this ambition being to not waste the advanced development of the blue streak, and to also not leave space exploration to the Americans and Russians. Britain also made diplomatic approaches to various European nations, the most significant of these being to France. Overtures between the British government and the French government on potential cooperation on missile research, and specifically on the potential use of the blue streak as early as 1957. Britain and France came to a mutual agreement to serve as the joint lead nations on the envisioned program, while also recognizing that other partner nations would be necessary. Both France and Britain approached various other nations to join on the collaborative program. However, negotiations with interested nations were often protracted, in part due to there having been a prevailing attitude of skepticism. Author C.N. Hill stated that many countries thought that the UK was seeking to foist an obsolescent launch vehicle on them and making them pay. The participation of many nations hinged upon gaining the endorsement of Germany, who was eventually won over and chose to participate. As a result of this diplomacy, it was decided to proceed with the formation of the European Launcher Development Organization, ELDO Group, headquartered in Paris. The founding members of the ELDO were Belgium, France, the United Kingdom, Italy, the Netherlands, and West Germany, while Australia, Spain, Switzerland, Norway, and Sweden had chosen to decline participation. The ELDO not only served the purpose of harnessing blue streak, but also fulfilled ambitions to produce a European rival to the American and Soviet launchers being developed and deployed at that time. In response to the rise of the ELDO initiative, following the study of various designs and concepts, the ELDO arrived at a three-stage approach which was given the designation ELDO-A. This was later formally named as Europa. According to Hill, the Black Prince and Europa were comparable launchers capable to delivering similar performance and roughly the same payloads, the overlap leaving little room for both programs. However, there was criticisms that Europa would take longer to deliver than the Black Prince launcher for no significant improvement, while suffering from the same core economic problem of being too expensive for scientific satellites, while too small for commercial communications satellites. In January 1965, the French thought the initial three-stage rocket design would not be sufficiently advanced to carry the size of payloads required, while another rocket referred to as ELDO-B, which featured liquid hydrogen-fueled second and third stages, came to be viewed as being a superior design, partly due to reduce the cost of the project via the elimination. It would still use the blue streak as the first stage. The ELDO later disagreed, but the French would ultimately get their way when ELDO-B became the foundation for the later Ariane launcher, which would first launch in 1979. Rising costs and restructuring. By April 1966, the project's estimated costs had increased to £150 million from an initial estimate of £70 million. By this point, hopes amongst several of the participants were not high that Europa would be suitable for the envisioned task. The Italians wanted to abandon the ELDO and instead participate in a single European space organization that would not be as nationally divided as the ELDO. The first launch had been originally planned for November 1966, however. The first two-stage launch occurred in August 1967, while the full three stages Europa 1 performed its first combined launch in November 1968. During the mid-1960s, Britain had been contributing 40% of the program's costs. In early June 1966, the British government fredmully decided it could not afford the cost of Europa and sought to leave the ELDO organization, one of the few European organizations by which point it had become a lead player. Britain's contribution was reduced to 27%. This was also at a time when satellite technology was on the verge of changing the world. However, the soon-to-be-common geosynchronous satellites necessitated being positioned at an altitude of 22,000 miles 35,400 km above Earth, which was far beyond the performance of Europa 1, being capable of launching satellites to a 125 miles 200 km altitude. In November 1968, a European Space Conference held in Bonn decided on a proposal to merge the ELDO with the ISRO, forming a pan-European space authority by early 1970, known as the European Space Agency (ESA). This organization would not be formed until 1975. Britain was lukewarm to the idea and did not believe that Europe could launch satellites economically. By 1970, the French launch base in French Guiana had cost £45 million, and in a year France became the most important partner in the project, then planning to build two-thirds of the rocket as well as owning the launch site. Although only on paper, Britain's involvement in the project has been much reduced, after being largely responsible with an Australian launch site for getting the entire project going in the first place. However, all of the launchers, to the very end of the program, were completely dependent on the British rocket used for the first stage. By 1970, the project was under a perceived economic threat from America's offer to fly satellites for foreign powers on a reimbursable basis. That agreement had been signed between ISRO and NASA on 30 December 1966, and by 1970 it was becoming clear that the advantage in having a national launch vehicle was insufficient to justify the cost. In 1972, NASA approved development of the reusable space shuttle, which at that time was largely perceived to eventually offer greater savings over the launching of satellites using an expendable system. These hopes, the shuttle delivering lower costs, would ultimately prove to be hollow. By 1971, over £250 million had been spent on the Europa program. The Europa 2 itself cost over £4. On 27 April 1973, Europa was abandoned. On 21 September 1973, the legal agreement for the L3, which later became known as the Ariane 1, was signed. Under this agreement, the Europa Roman 3 was formally cancelled, while the L3S would be developed as a multinational project. From the onset, this new launcher was to be developed for the purpose of sending commercial satellites into geosynchronous orbit, unlike many other competing launchers, which had been typically developed for other purposes and subsequently adapted, such as ballistic missiles. Division of labor. Workshare on the program was a politically charged matter. Tasks were to be distributed between nations. The United Kingdom would provide the first stage derived from the Blue Streak missile, France would build the second, and Germany would construct the third stage. It would carry a satellite, which would be designed and manufactured in Italy and weighted roughly a ton. The telemetry was to be developed by the Netherlands, while Belgium was to develop the downrange ground guidance system. By 1969, the ELDO was beginning to realize that dividing work up by country led. This disjointed structure has been accredited as having been responsible for the lack of successful launch. In effect, there had been no single authority or group that was entirely responsible or in control of Europa. Notably, in November 1971, the West Germans publicly blamed the failure and explosion of Europa 2 upon immense divisions within ELDO. Program stages. The Europa program was divided into 4 separate projects intended to follow each other in succession. Ultimately, only 2 of these projects would have any launches conducted, the third project being cancelled, while the fourth remained a case study only. Europa 1, 4 unsuccessful launches. Europa 2, 1 unsuccessful launch. Europa 3 cancelled before any launch occurred. Europa 4 study only later cancelled. Design. Payloads. The payload for the rocket was overseen by the European Space Research Organization, ESRO. Satellites were proposed to be launched by 1969 or 1970 in a circular polar orbit at an altitude of 125 miles 200 km. ESRO organized the development of early satellites such as ESRO-2B Iris, built by Hawker Siddeley Dynamics and Engines Matra. In 1967, it was decided the payloads were to be launched by 1970 from French Guiana, not Australia. In April 1969, Britain decided to invest in a satellite television project by the European Broadcasting Union. By the early 1970s, the French-German Symphonie Communications satellite were in production, but by then Europa was cancelled in November 1971. First stage. It was tested 3 times in 1964 and also in 1965, with dummy upper stages in 1965. It was assisted by the British National Committee for Space Research. The chief project engineer of the rocket's assembly at the Space Projects Division of Hawker Siddeley Dynamics was Dr. Geoffrey Pardo, also the project manager of Blue Streak from 1956 to 1960 when under de Havilland. In August 1965, the Blue Streak was tested static firing trial with complete full-weight dummy upper stages at RAF-Spadeadam. The site was owned by Rolls-Royce, with first successful firing on 23 September 1965 lasting 135 seconds. 5 days later, the site was visited by the Minister of Aviation, Roy Jenkins. In January 1966, it had been transported to Adelaide, Australia, for launches later that year. Also in the UK in 1967, the go-ahead had been given for the UK separately developed 3-stage Black. Britain then withdrew from ELDO to concentrate on the Black Arrow, but was committed to supplying ELDO with 2 Blue Streak rocket stages a year until 1976. At this time, in 1969, Britain was spending £30 million a year on space, controlled from the Space Division of the Ministry of Technology. Britain was still dealing with and funding ESRO. Due to Britain's withdrawal in 1968, ELDO in June 1969 had other ideas than staying with the Blue Streak launcher for Europa's first stage to give technical work to countries that were still loyally part of the organization. Unfortunately, few other European countries had sufficiently advanced technical knowledge of rockets at that time. The Blue Streak had worked much more successfully than the other engine stages. Nonetheless, Blue Streak, ELDO's most successful rocket to that date, was replaced. On 28 April 1970, at a meeting in Paris, ELDO replaced the Blue Streak with the French-made Diamant. Britain's most significant involvement with the project came to an end. The following year, Britain would put its own rocket program, Black Arrow, prematurely out of operation. By 1970, Hawker Siddeley's Blue Streak launcher had cost £100 million to develop. It was still planned to be used on Europa until 1973, when Diamant would be used as the first stage. Blue Streak was used for the Europa 2's one and only launch on 5 November 1971. Second stage. The French had developed rockets through their Veronique, which was originally planned to be the second stage. The Coralie was to be tested at Kalam Bechar in the Bechar province of western Algeria. Tests began in December 1965 at Vernon, Eura in France, west of Paris. The first successful firing was on 28 November 1966 in northern Africa. Société Européenne de Propulsion SCP at Vernon would later develop the Viking main engines for Ariane. Third stage. This was made in Germany by Entwicklungsring Nord Erno Raumfahrttechnik GmbH, based in Bremen, from 1969. The German consortium itself was known as Arbeitsgemeinschaft Satellitenträgersystem SAT, which consisted of Erno and NBB. Although assembled by Erno in Bremen, The engine was made by Société d'études pour la propulsion par réaction séparée, part of SNECMA in Villarache. On 2 July 1969, on a launch at Woomera of the three-stage 108-foot 33M rocket, the Astris third stage failed to light after the other two had successfully fired. After the third stage, an apogee kick motor would be used to put a satellite into a synchronous orbit. ELDO would later develop the second stage for the Ariane launcher at the Vereinigte Flugtechnische VFW factory in Bremen, later owned by Daimler-Benz Aerospace, then Daimler Chrysler Aerospace DASA. Operational history. The first test took place at 9:14 am local time on 5 June 1964 at Woomera. Thrust was terminated after 147 seconds, 6 seconds earlier than planned. The point of impact was 625 miles 1,000 km from the launch site instead of the intended 950 miles 1,500 km. It reached a height of 110 miles 180 km and a maximum speed of 6,400 mph 10,300 km/h. Near space is considered to be around 60-70 miles 9,110 km. The craft's structure was built by Hawker Siddeley Dynamics, and the rocket engine were the Rolls-Royce RZ-2. At this stage, the French and German rocket stages were mere fiberglass scale models. The first full-size launch, weighing in total 104 tons, took place at Woomera on 24 May 1966, with dummy upper stages. Tests were conducted by Australia's Weapons Research Establishment and the French Laboratoire de Recherche en Balistique et Aérodynamique based at Vernon. After 2 minutes and 15 seconds, 6 seconds short of the planned flight, the rocket was destroyed because an impact predictor reported it to be veering west of the planned trajectory. However, the rocket was exactly on course and inaccurate readings had been picked up by a radar station 120 miles 190 km away. Two-stage testing was planned for June 1967. At 11:12 p.m. GMT on 30 November 1968, the first three-stage Europa 1 launcher put a 550 lb 250 kg Italian satellite model into orbit. The first launch from French Guiana on 5 November 1971 was also the first launch of the four-stage Europa 2. It exploded over the Atlantic after 3 minutes. It landed in the sea 302 miles 486 km from the launch site and had reached a height of 40 miles 65 km. Overall, the Europa program had been heavily marred by technical problems. Although the first stage, the British Blue Streak, had launched successfully on each occasion, either the second or third stage would fail during every time, preventing a fully successful launch from being achieved. This disappointing performance heavily contributed to work on the program being terminated. Europa rocket launches.